technically, Earth is not a perfect sphere. Earth is not a perfect sphere. It is kind of bulged along the equator and flattened along the pole. So if this is our equator, basically, if I find out this radius and compare it with this radius, sorry, sorry guys, yeah. If I compare this radius and this radius, if we call this as R equator and R pole, R equator is greater than R pole. So this is the truth. Now, does this affect acceleration due to gravity? So what does our formula tell? Formula tells that we have G, which is equal to Gm by R square. So basically G is inversely proportional to R. So if G is inversely proportional to R, actually it is inverse square law. So if this increases, obviously this reduces. If this reduces, this increases. That is the relationship that they have. So technically at the equator, since this particular value is maximum, the denominator gets bigger and G gets smaller. So if I kind of plot a rough diagram of G value, something like this, if I plot, again, this is something that I'm making up. It would be something like this, guys. So it will gradually reduce. That's what I'm trying to show. So at the poles, the radius is minimum, so G is maximum. So here, this is value of G. Value of G along this axis. And this is your length. Along the length. Along your longitude, latitude, I get confused with that. Along the longitude, actually, I think longitude. If it's latitude, please write it as latitude. So basically, it is minimum at the equator than at the pole. As simple as that. So the difference is actually around 0.5. And yeah, this is around 95% of G at poles. So that's it. So that's a small note for you guys. So you can have a look. Let's read through. Earth is not perfect sphere. It's slightly flattened at the poles and bulged at the equator. This shape is called an oblate spheroid. So the radius at the equator is larger and the pole is smaller. And as per this, radius increases, G decreases. As the radius decreases, G increases. That we know. So applying to Earth, we have at the equator, denominator is bigger, so G is smaller. At the pole, denominator is smaller, so G is larger. So G at the poles is slightly greater than G at the equator. The difference is smaller, about 0.5%, but it is real and measurable. So online summary. Because Earth is bulged at the equator and flattened at the pole, the equator is further from the center. So G is weaker there and stronger at the poles. And that's that.